Hello and welcome back to Short of Search classes. This is real analysis and we are solving problems on sequences in a little quirky way. So if you have any doubt, just call or WhatsApp this number at 9367933076, or if you want to check out more cool content, head over to our website and www.shortofsearchclasses.com. Okay, so let's begin with our problem. So the question demands that prove the sequence. Prove that the sequence given by 2n minus 7 divided by 3n plus 2. This is number 1, monotonic, increasing, is bounded, and number 3, tends to the limit 2 by 3. So how do we go about this? So let's suppose fn equal to the sequence 2n minus 7 divided by 3n plus 2, and from here we have fn plus 1 minus fn is equal to 2n minus 5 divided by 3n plus 5 minus 2n minus 7 divided by 3n plus 2, and this is equal to 25 divided by 3n plus 5 into 3n plus 2. I'm not going to go through the calculations. I'll just say that you just substitute in here, you just substitute n plus 1 and you'll get this, and here is when you substitute n, and if you just do your simple math and you'll get this is equal to so. Alright, so let's proceed. This is valid for all n belonging to the natural numbers, and on simplification we have that this can be written as if n plus 1 is greater than fn for all n belongs to the natural number set. So from here we say that from here we infer that fn is monotonic, increasing. Okay, so the second says that we are required to prove that this is bounded. So fn equals the sequence minus 1 minus 3 by 8 minus 1 by 11, 1 by 14, 3 by 17, so on and so forth. And so we have, thus we have fn is greater than equal to minus 1 for all n belongs to the natural number, and from let's suppose that, and let's say that 1 minus fn is equal to 1 minus 2n minus 7 divided by 3n plus 2 is equal to n plus 9 by 3n plus 2. This is greater than equal to 0 for all n belongs to the natural number set, And so from here we can say this implies that Fn is bounded above by 1. Okay, for all n belongs to the natural number. So from, let this be 1, let this be 2. So from 1 and 2 and 2, we have that f is bounded by, Fn rather, is bounded by -1 below and 1 above. So we can say from here that Fn is a bounded sequence. Okay. Now number 3 is that we are required to prove convergence, and we are required to prove that it converges to 2 by 3. Okay. So how do we go about this? Now from here we have that Fn is a bounded sequence, and from the previous one we have that Fn is monotonic increasing. So from the theorem that, okay, let me just write, since Fn is monotone increasing and bounded above, so it converges, right? Okay. So limit n tends to infinity, Fn is equal to limit n tends to infinity 2n minus 7 by 3n plus 2, and as we have solved in our higher secondary level, we will solve it as so. We have z 7 by n, and this will become 3 plus 2 by n. Okay, and this will reduce to 0, this will reduce to 0 as well, so this will become 2 by 3. Right, so what we have concluded, we can conclude that Fn converges to 2 by 3. Thank you for watching this video. We'll be back with more concepts and sums in our next video. Please stay tuned.